All right, so increasing and decreasing functions, day 2. Yesterday you learned the test for increasing and decreasing functions. If f prime of x is greater than 0 for all x in a, b, then f is increasing. That was our takeaway. F was increasing. If f prime of x is less than 0, f is decreasing. Okay, so that's a little bit of a summary. If f prime of x equals 0 for all x in a, b, f is constant. All right? Now the actual first derivative test, let c be a critical number of a function f that is continuous on the open interval I containing c. If f is differentiable on that interval except possibly at c, then cf of c can be classified as follows. If f prime of x changes from positive to negative at x equals c, then f of c is a relative maximum. And think about that. If your slope's positive and then negative, you see how you'd have that relative maximum. If f prime of x changes from negative to positive at x equals c, then f of c is a relative minimum. And hopefully that makes sense. Your slope's negative and then positive. Yeah, I would have a relative minimum. Now let's take a look at an example that will explain this. Here we have a piecewise defined function where to find the intervals where f is increasing and decreasing. Identify all points that are relative maximum and minimum points and justify your answers. Use your results to graph. Well, I kind of want to graph it first, but I'm going to kind of do a little bit more of the calculus. So when x is less than or equal to negative 1, f of x is equal to 2x plus 1. So that means f prime of x is going to equal, that's f prime of x, not f of x, f double prime. That's just f prime of x is equal to 2. So really, at x equals negative 1, that might be the only time that I really need to test things for this piece of the function, because I might have something happening at negative 1, but here I don't have a change in sign. When x is greater than negative 1, f of x is equal to x squared minus 2, so f prime of x is equal to 2x. So 0 is a critical number. So here I might take this negative 1, I'll take 0, and that's all I have. And then I want to take a look at f prime. Well, all the way up to negative 1, f prime is positive. Then, as x is greater than negative 1, f prime goes negative, and then f prime goes positive. So that would mean f is increasing from minus infinity to negative 1, union 0 to infinity. And f will be decreasing. F is decreasing from negative 1 to 0. Graphically, okay, do we have any relative maxes, relative mins? We have a relative max at x equals negative 1. The relative max is, and I plug in negative 1 and I get negative 1. We have a relative min at x equals 0. The relative min is negative 2. Because when I plug in that 0, I get negative 2. So if we think about this graph, we think about this piece, got a slope of 2, and essentially here are some points on that graph, and then we get quadratic. There you go. And it makes sense. We have a relative max here and a relative min there. Hopefully that helped. Thank you very much.